Now, more than enough rambling for me. I'm sure you're tired of it, so time for the real content to begin. Our first keynote this weekend is Dr. Chenxi Wang speaking about navigating the AI frontier, investing in AI in the evolving cyber landscape. Without further ado, may the 4th be with you, and welcome to the stage, Dr. Wang. If this works.
Okay, thank you. Thank you, everyone, for coming. This is awesome. BSides is one of my favorite conferences. Jack Daniel will be proud to see what it is today from an idea he had many years ago. He's an old friend of mine, so I'm very happy to be keynoting here today. I'm going to be talking about AI and cyber. I'm a cyber person. I'm an investor now, but used to be a technologist. So today I straddle between business world and technology world. So my talk isn't as technical as some of those that you'll see here, but it'll give you an interesting perspective coming from someone who look at technology from investment and from a money-making standpoint that could be interesting to you. All right, a little bit about myself. You can tell this is AI generated. You know, there's the text all mangled. So I was asking someone the other day, I was like, when are they gonna work on better text? But see, even just that part will take a lot of programming effort to make it happen. So I am a computer scientist. I have a PhD in computer science, started as an academic, teaching computer science in Carnegie Mellon as my first job. And then I came to industry and did a number of things, product strategy, market research, executives at large and small companies, and now I'm an investor. So I think I have a lot of different perspectives on why a piece of technology works or doesn't work, and that's what I'm going to talk about today. These are some of the interesting statistics that you probably already know. It only took ChatGPT 5 days to reach 1 million users. The same number of users took Instagram 2 months, Spotify 5 months, Facebook 10 months, and Netflix 3.5 years. So it's very, very different game we're talking about here. I looked at some stats on how many companies are using large language models, at least experimenting, and the estimate is that 200 million companies around the world. So that's not a small number. Okay, does that work? And this is from the latest AI report from Databricks. They talk about what kind of things enterprises are doing with AI, and it's kind of eye chart. You can't really read very well, but if you direct your attention to over there, there's detecting security threats and account takeover attempts. That's kind of fraud related. And analyzing communication for phishing attempts. In my world, you know, I get lots of early stage company pitches, and I see a lot more than that in terms of AI applying for security as well as securing AI. So we'll talk a little bit more about that. But a very interesting question to ask is, there's been a lot of money spent on AI infrastructure. NVIDIA stocks keep going up because a ton of companies buying their chipset. But an interesting question to ask is, if you build infrastructure, if you build the bottom layer infrastructure, you should have the layers on top at some point, and the layers on top. That will make sense. That will be what a market looks like. Today, we're seeing lots of infrastructure build out, some data layer build out, some application layer build out, but the usage of application is still small. Even though 200 million companies are experimenting with language models, they're not yet in the critical business process. So what does that mean? There was lots of interesting talks about golden age of AI. AI has been around for a long time, but really since November 2023 is where it became a huge boom. We're not quite at the golden age. Inferences and training are still expensive. Now, this is one thing that a lot of people building AI products don't know. When they build a product in their labs or in their VPC environment on AWS, they're experimenting with it, right? So training on sort of a small set of data is fine, and they're doing their test inferences fine. But the minute they take it to a real production environment, in customer's environment, the number one thing that both the customer and the product team are surprised about is how expensive it is to do inferences. And many people walk away and say, hey, enterprise users walk away and said, oh, it's kind of fun to see something interesting generated by AI. But at the end of the day, the added benefit that it provides me is not yet worth the cost that I will put in for inference costs and run the models and all the other privacy security concerns. So that says to me that we're not yet in the pervasive deployment stage. We're in the experimental stage. Something will have to change in the cost equation for this to be pervasively deployed. So think about all these companies are building AI agents here, AI agents here. This year, winter YC batch has 170 AI companies. 170 out of, I think, 200 companies. So everybody's doing AI. Many will not survive because cost, they can't get hold of GPU cycles, or what they're doing is a thin layer on top of large language models that everybody else can do. So we are still learning to walk. Some of the things I've been noodling about, right? So I have a 14-year-old. My son, my husband and I are both PhDs in computer science. My son couldn't be less interested in programming. And he's always been that way. And since he was like 10, we were like, oh, how about we teach you Python? How about we teach you, whatever language, we can do it. We're like, 2 PhDs in computer science. He's like, yeah, no, thank you. And my husband and I will always be like, oh, what's going on? And he's most interested in fishing, to be honest. Yeah, and I even tried to have him write a fishing program, so do a histogram on the number of fish he caught each day and stuff. And he's like mildly interested, but he really could not be bothered with the specifics of programming. Like learning syntax is he's like so bored. And I've always been like, oh, you need to. But recently I'm like, oh, I'm not sure he needs. Maybe he doesn't, right? Why? Because I think software engineering is going through a huge transformational change. It's not the software engineering that I know when I was learning programming. I started Pascal. I don't know if any of you learned Pascal, right? So I went from Pascal to C, C++, Java, and Python, and all that. I tell you, a lot of people use Python. Python is a shitty language, but that's okay. So software engineering is turning into model engineering because AI engineering will subsume parts of the mechanics of software engineering. Now, what does model development, model engineering mean? Some of the mechanics, I said the low-level mechanics, will get subsumed by code generation capabilities that everybody uses. But the telling it what to do, testing the model, and really understand how the mechanics of cost of running the model as an application, those things will still be very much manual and very much done by engineering teams. But it's not about do I have 2 equal signs versus 1 equal sign? One's assignment, the other one's equality test. Those things will be done by AI. So we should not be teaching our kids or young folks software engineering the same way. We should be teaching them how to leverage a model, a set of functionalities that's already built, kind of like open source today, but not the same. I'll tell you why. And learning what is important for their application to be manifested in this AI stack. The second thing that I've been realizing as I do this kind of, we do work all the time when we get into a new investment area. The work meaning that understand the trends of the market, as well as understanding the fundamental building blocks of technology, and look at what the gaps are, and look at business opportunities. One of the things that it's very apparent to us is security, enterprise security and consumer security, if you will, really take on new dimensions. And what are those dimensions? Security, a lot of time, is about making a decision on a set of data, right? Is this thing malicious? Is this thing suspicious? Is this thing good? And in the past, is really about the game of, who has the relevant data, who has the right data at the right time, so you can make a better decision than the attackers. Or maybe the attackers will make a better decision than you because they did their reconnaissance well. In this world, in the AI world, what we are seeing is the data inequality between defenders and attackers are kind of disappearing. You still have inside the enterprise, inside your company, you still have more data that other people don't know about, but the window of that being true is kind of diminishing. I got a demo, a toy demo, still today, but it's very astounding to me. So this person was able to set up a stage environment where he can pull information from certain infrastructure components and security products, and then ask the question that what is the biggest gap in the security architecture overall, and the AI will answer for you. And he's able to demonstrate that some of the most interesting security data he can easily convert into flat text data files, and then generate embeddings, put into a vector database, and then have just a lightly modified third-party model to turn through this. So what that means is lots of point products that going forward may disappear because they are operating on, I've got this set of data and I have my proprietary analysis algorithm. I can tell you certain things about the set of data that you don't know without my analysis. But now a fairly generic third-party language model can do that for you as long as you can transform the data into the format it can consume. So that's very interesting. But also think about doing that from external standpoint, right? So I have an example later. You could potentially get to a point, ask the question, does Bank of America use product X? And does Bank of America use product X in such a way? And when you get to that kind of information, then you might be able to direct your attacks much more in a targeted way, in a malicious way. And there's also the data economy is taking on also a very different set of economics with AI now. So if an underground criminal group wants to train their own attack language model, right? So there's ways to get data, it's different than in the past, buying credit card data, buying identity data. Right now, it is really buying a set of data that can really direct their model to make interesting decisions. So we already have seen in the underground economy where data brokers are buying, selling different things. That's not necessarily for generating an attack package per se, but it is for training models, fine-tuning models. So we expect to see that more and more going forward. So this is a toy example, but I have seen this in a demo, which I kind of was like, ooh. So this is a CVE it's a real CVE that applies to this version of Ubuntu, and there is there's an exploit in the wild can take advantage of that vulnerability. Now, let's say you know that a particular product Y protects against that exploit, right? Lots of security products, once the exploit's out, you can detect it and whatnot. And we know that this organization that doesn't use Y, or this organization uses a product X that only works in the environment Y doesn't exist, right? And once we know that kind of information and tell you who uses what product, is actually pretty easy to get these days. And I would not be surprised if the large language model are able to get their hands on those data, right? So you very easily can ask a question and know that you could unleash this exploit on this company. I don't know how many of you have. Maybe you guys all have. Have you asked ChatGPT about yourself? Yeah. You have, right? Yeah. But the back there, yeah? So I've asked very specific questions about myself that are not necessarily widely known, and it knows. It's kind of scary. So next time, try something obscure about yourself. But I'm out there, so maybe a little different. But it knows a lot of things that we don't know. And you could imagine a attack brain that is kind of similar to ChatGPT. I mean, there is one out there that the underground economy uses, but I'm talking about one that is as smart as GPT-5, that's being trained by nation states, and that is being worked on. So as defenders, our jobs are getting more and more interesting and difficult. Okay, so this is what I was getting to is, in the past, some of the security defense relies on us having proprietary knowledge about our environments and having more data than attackers, and that gap might go away. And then what happens? Also, specifically in terms of data security and application security, the requirements are also changing, right? So I actually have an application security background. I wrote a compiler for my PhD thesis. It's an obfuscation compiler, and I still remember sitting there so many hours coding to get the compiler to work. Building a compiler is not for the faint of heart. So AppSec is near and dear to my heart, and I've done a lot of work in AppSec, including sitting on the board of OWASP. And now I look at what AppSec is going forward. It's a very different game. So let's talk about data security for a second. Traditionally, data security is about data discovery, classification, access management, and maybe permission management, so that we can assure that the right data is accessed by the right people, right? So all these things But today, actually, the boundary of data goes into things that you may not necessarily care about in the past. It's not your own data sitting in your data store database. It is the data that goes into training the AI model. It's part of the data you're using. It is the data that's going to fine-tune the AI model. And all that, how do you test the right data is being used? How do you test that the data is not biased, it does not have malicious intent. All these now are part of data security / application security domain. And as far as I know, we don't have a good handle on data discovery there, data classification there, as well as testing of the different categories of data, right? So I would love to have A/B test, like same model, right? So same like vanilla model, and I train with a set of data without this particular set, or train with the data with this particular set, with a control test to see what the difference is for the two models. I haven't seen a lot of research work there, but it would be a really interesting thing to see. Sensitivity test of models on data and prediction test on data, it's all very interesting. So AppSec really becomes, I say model sec. Application testing is model testing, pen testing becomes red teaming against data. Actually, in 2010, I did a keynote for OWASP Global Conference, and there I talk about how we should be gearing up for red teaming and AppSec testing of AI models. And it only took more than 10 years for, for this to be a reality. So some of the specific things about AppSec. This is really small. I can't read with my old eyes, so I have to see. So in the past, AppSec's static analysis, dynamic analysis, penetration testing, all that stuff that you guys do and you know really well. But now we are looking at a set of new added things, right? So what data goes into training the model, right? Do we have a handle on the different sets of data? Are they, like for instance, if you want to train a model to recognize architecture structure in a set of images, right? You can give a different image, different architecture style, different buildings, that's all great. But have you fed data that's a little bit darker images versus bright image? Have you fed images that are a little bit distorted and images taken in a really bright reflective light? All that things that you have to understand. The same with security, right? And model supply chain. How many models are chained together in this model? Right? There's sometimes the open source model actually uses other model on the back end. Test against specific samples, specific cuts, specific requirements you have for your understanding and for your use cases, and do you have the right test case, the right exploits against it? And red teaming on prompt injections, the robustness against prompt injections and adversarial data training test. All those things should go into a robust enterprise product, but it is not today, right? In fact, I know many of the enterprise products, including security products, are training with LLM on the back end. So they actually come with an LLM, either in the cloud or in your own infrastructure, and it may not be exposed to the customers, but it's doing some work on the back end to help you do things, right? And sometimes you don't even know it comes with it. And what happens when your data is in this LLM that you don't know about, and it's not really tested the same degree in robustness as the application code. And it impacts DevOps as well, right? So is there a way to increase the, because I can't read, I have to always turning around. There's plus sign, okay. Now, of course, the cursor doesn't work. Well, anyway, we'll just wing it, okay? Okay, thank you. So in DevOps, okay, better, okay. So in the old DevOps world, so I played in container security for quite a bit. So that figure 8 is very famous there, right? So we went from monolithic code base to more the continuous release versus once a year release. So going from like big code base to microservices, and you deploying in a different way as well. Microservices is really interesting because it has changed the way we test programs, we deploy programs, and the way we kind of have identities percolated throughout the system, right? When you have AI models all over the place, right? So think about in the future, what you have is instead of microservices, you have micro models that's talking to each other through APIs, through some kind of data exchange channel, may or may not exist today. So one model may be drifting or maybe hallucinating in that whole architecture. What's going to happen for the collective decision making that is done by those collective microservices talking to each other, making a decision? We don't know. I mean, this is all very, very early stage work, but it will happen. So in the future, mark my words, microservices are micro models talking to each other. So DevOps are going to be very different. You're deploying a new model in this architecture and leave the other models alone, and you better be robust enough that the whole application, the whole model chain is still making the right decisions after you continuously update and deploying those models individually. The third thing that's interesting to think about is flipping a little bit is AI model as a threat vector, right? So we are all security people, so we think about introducing new technology components into your environment could be a potential threat vector. And this is also, I think I did not put the citation here, it's my fault. I think it's from Databricks, but you can see that the number of large language models being deployed, sort of the ChatGPT there, and launch. This is the red line is the third-party LLM APIs are going up, right? And so there's a prompt in like people using it on the command line. There's also APIs. APIs indicate sort of serious usage, right? Because you're building on top of it as opposed to me just asking, what's the best restaurant in San Francisco, right? So if we have a lot of people who are using those third-party LLMs as a universally deployed code base, and if that particular LLM has a security vulnerability, it could take many organizations down. Just like we talked about monoculture in the past, and right now we're seeing some of the very popular ones popping up on top, right? OpenAI, Anthropic, and Llama. Llama is very widely deployed in Llama 2. So who is looking after security for those models? Think about SolarWinds. We could have a SolarWinds of models, right? And what will happen to the industry and to all the applications that are built on top. So these are kind of the new things that we've been thinking about. I want to bring it out to just have a discussion here to show you that that's some of the new issues and concerns that not only are impacting our industry, also as an investor, I look at this and say, oh, that's interesting questions, whether I look at it from two ways. One is market trends, the other one is there innovation opportunity for a new product or new piece of capability coming in town. And we talked a lot about this, and this is a slightly different point is open source, right? So we know many of us experiment with open source software now with open source model. Now, is an open source LLM the same way that is open source software? No, it's not. So they may give you the code, right? But if they don't give you the data that it's trained on, it's not 100% open source. They don't give you the weights in the model is not 100% open source. So they may say, hey, take this open source model, but all those important factors are obscure to you. You may not know the same way about this model as you would of open source software. So that's another thing to keep in mind. And the last thing that I'm really interested about is AI for security as an opportunity, right? So earlier I saw a demo where they bring in, XDR data, they bring in email data, they bring in, I think it was some toy SIM data, and they all transform into flat data text file and fed through sort of a framework to do indexing and embedding generated, put it into a vector database, and then is using an LLM against that. And is able to generate actually pretty interesting questions about, what's the most largest gaping hole in the security architecture? It will tell you. It's still a toy example today, but I think with the improvement of technology, we could see that as an opportunity. So AI for security, being able to process large volume of data in a way that's targeted for a certain task is happening, right? So we see things like automated root cause analysis, which is, taking in data and look at what are the root causes for other issues in the past and using that to train a model and answering root cause analysis using similarity search and data embedding to answer those questions. The accuracy is not quite as high as I would like to see it as a production product, but it's getting there. In the past, 4 or 5 months, I've seen some of the work that's already, the accuracy is improving quite a bit. Obviously lots of boosting productivity usage of AI applications. So I've been collecting enterprise deployment of AI models and asking them, what are you doing? Or not just in security, but in general, just understand the usage of it. There's a large insurance company, potentially number 1, number 2 in US. You guys might, those in the US would know there's an open enrollment period for health insurance, right? It's typically starts in November. So this company, in November, starting November 1st, they'll hire 25,000 temp workers, and all they do is sitting on the phone, taking questions from subscribers, their healthcare policy subscribers, calling in to say, oh, does this policy cover this? And how much do I have to pay out of pocket if I subscribe to that policy, right? So, and that, people like me don't call, but a lot of people call. And when you call, somebody has to look through a ton of documents to give you the answer. So, and this company, this health insurance company has been collecting data about the performance of human agents, right? So for many years. So the accuracy of human answering questions, they have tens of thousands of documents, right? Some of maybe less access than other, but the human agent accuracy is 66.7%. And then they've been adding on AI agents just in the mix to see what the AI agent performances are. And the AI accuracy is 99% right? So a lot higher. Also, guess what? A lot of people call in are in bad mood because they are maybe forced to pick a new policy. They may be sick, right? And the human agent has predominantly, universally, really low empathy score because they've been, the people are not in good mood when they call in. The AI agent doesn't mind, right? They don't get tired, they don't get mad, so they have higher empathy score. So this company, last year, still 25,000 AI agent, and this year, they said they're going to reduce it to 12,000 human agent, from 25,000 to 12. And supplement it with AI agent. And next year, they are thinking they're going to reduce to 0, maybe. So that is a concrete example of how this is generative AI. They're actually training their own model. But what they are really afraid of is they're like, well, the human agents today are using some part of the AI agent as to help them answering questions. And they said it's actually pretty easy to pull out their business logic from the AI model. And if you work in model building, you'll know that from a computer science standpoint, asking a set of interesting questions will let you understand how this model is built pretty easily. And so they are really afraid of how a competitor could send a human agent to work for them and ask questions and really understand how they underwrite certain policies and how they monetize certain policies. And that's a big concern of theirs. But the business benefits is very visible. And so they are going for it, but they are looking at how do I obscure this AI model, how do I protect the prompt that the human agents are using so that people are not pulling out my critical business logic. Anyway, so, but in the security world, how many of you have heard about RAG? Right, yeah, quite a few. So in OpenAI trained their model on vast available data on the internet. Whatever it's there, they find it. They crawl the internet, they find things publicly facing. They train on documents, images, and all that stuff. The thing that they don't have access to are your internal data, right? So like your own legal documents, they probably haven't crawled it unless it's leaked somewhere. So your own policy documents, your emails, maybe not available, right? So in order to make a decision that based on your own data, a lot of times what you supplement a public LLM with a RAG model, right? So retrieval augmented generation, right? So it's RAG. And what that is if you look at a human ask a prompt to the computer, if no RAG, it will just take the prompt and give to the LLM and generate a result and come back. With RAG, what it does is it packages up the query, go up to a internal embedded internal vector database that's been already worked on using internal data. It's been chunked, it's been indexed, it's been embeddings generated in this. So your policy document, your email could already be in that database. So this brain here, this logic here will take the user query and send it up there to your own vector database, and that database will perform similarity search on the query and getting back the data to this logic here. And this logic will take whatever the data that's returned back from the internal vector database, package it up together with the query that's called the prompt before the prompt, and send that entire prompt to the LLM. And the LLM will then answer the question based on both its own internal logic and the private data that's supplemented to it. So this is called RAG. Now, if you think about we're doing security questions, we're asking security questions, what you need to do, build your internal vector database, is taking security data, right? So what are security data? What do we have? We have endpoint logs, we have XDR logs, we have network logs, VPC flow data, we have email data, we have policies. Some of them are structured, some of them are not, right? Log data is very structured. And turns out the vector database doesn't deal with structured data really well. It wants to deal with the unstructured data. That's how it is. And it doesn't quite make sense to take log data, which is very structured, and transform it into a vector database. So what do we do? There are better ways to transform the data and chunk the data and put it in a way that's consumable by LLMs. And that is an interesting area of innovation that I'm looking at. But if you think about it, taking, if the internal sources of data, right, a lot of them are security structure data, and you put it into this vector database using LLM, and you look at this whole thing, it's able to answer questions, able to point out things you need to do. You're like, well, what products can I replace with this? Which is really interesting. I have one more minute. So really interesting question, right? So I would challenge you to all think about it. Going back, you say, how many security products I have today in my environment? If I use this architecture here, and assuming it's doable in the next 2-3 years, what products do I not need? And I've been thinking about that on a daily basis. I think it's a really interesting question. Okay, so I don't have a lot of. So just one thing, we are investing in cyber and AI. My firm is called Rain Capital. We're very early stage investment firm. So if any of you have an idea on AI and cyber, or just cyber, because we are cyber investors, please find me, Chenxi at raincapital.vc. One thing. Can I just finish this before I turn it over? There are two areas in AI that people typically invest in. There's models, that vertical industry models, and there's AI infrastructure. Infrastructure is more horizontal, right? The risk in the vertical models is that you may build this healthcare model, fintech model, but a lot of them are only thin layer on top of third-party LMs. If two guys can build this on a weekend, another two guys or women can build this on the weekend. So as an investor, you don't want that. You want to weed out the thin layer on top. But because there's no technology mode. For infrastructure, there's usually more technical meat in the build. However, you have to be very careful how close you are to the black hole. The black hole is what OpenAI, what Anthropic will do. So if you build infrastructure on something that they will build, they'll take your market away completely. So you have to say, okay, I'll work on infrastructure, but cannot be too close to the black hole. And with infrastructure, it's harder to go to market. So there's both sides have risk. So with that, I'm just going to, one thing here. So today we have about 200 billion market global spend on security. About half of it is on professional services. Literally about half is professional services on security. And we think about 80 or 90% of that work can be automated by AI. So that's a huge, huge opportunity. So with that, I'm gonna close, and the future is AI and security, and you are in the right place. So I congratulate you for being in the right place, right time, and I hope to hear from many of you on new ideas, new innovations, and maybe new companies. Thank you.